runs 400 meters in 44.16 seconds. That is a fast time. Show how the speed can be converted to miles per hour. So I have 400 meters in 44.16 seconds. And I'm going to convert that to miles per hour. Okay, what do you got to do? Conversion.
To minutes.
Chemistry.
Or wait, is that?
You got to put the M on the bottom.
Okay, so the meter's on the bottom, so we're going to go 1,600 meters is the same thing as 1 mile. So Axel's going to run the 1 mile. That's the same thing as the 1,600 meter run 4 times around the track. Brian's going to run the 2 mile.
So that's something that we would need to know.
We need to know that equals.
They would give you that conversion. Okay, they would give you that.
Wait, you're running the 2 mile?
I'm not running the 2 mile.
Just kidding. All right, and then we're going to go the next one here. He always run the 2 mile. So now we've got to convert seconds to hours, and there's 60 seconds in a minute, and there's 60 minutes in an hour, so there's 3,600 seconds in 1 hour. And you can see as you kind of organize here that now your seconds are going to disappear and that your meters are going to disappear, and finally you're left with miles per hour. So you take that 40 times 3,600 and divide it by the stuff on the bottom, you get like 20.3. Everybody good on general conversion? Yeah, not too bad. Okay, a shape has a perimeter of 6, a shape has an area of 20, and a shape has a volume of 15. Determine the perimeter, area, and volume if the sides of each shape are tripled. Tripled. We can make this problem very simple. Please just focus on the dimension. If you're to label perimeter, okay, perimeter of 6, that'll be like 6 feet, not 6 feet squared or cubed, right? It's just gonna be 6 feet. So therefore, that would be of a singular dimension. So we just multiply it by 3. So perimeter 6 times 3, and we get 18. The next one, the shape has an area of 20. What dimension is area? 2. So therefore, we're not going to multiply by 3. We're going to multiply by
6.
9.
9.
Oh.
3 squared. 3 squared. Okay, 3 squared, so we get 180. We'll try next one. The volume. Volume is dimension 3, so we're not going to multiply by 3. We're going to multiply by 27. Good. So we get 405. 3 cubed. Okay, so consider the dimension and then either square it or cube it. All right, section 7, geometry applying geometric properties. A 30, 60, 90 triangle, shortest leg of 20. The shortest leg is length of 20. Who can tell me what is the length of the hypotenuse? 30, 60, 90, what?
40.
Why?
Because it's twice as
Yeah, how do you get the longer side? Times the root of 3, good. Yep, know your 30, 60, 90 properties. These two shapes, they are similar. What is true if shapes are similar? What's true about their sides? They are, so the P, proportional. Yeah, they're proportional. So that means if you take this side over this side, say 18 over 30, that's going to be equal to, and let's find side Y. So what corresponds with side Y is 15. So we'll say 15 over Y. And then you can go to work from there. So 30 times 15 divided by 18, I think you get Y is equal to 25. Very good there? Okay. It says determine the missing angle. Nobody's been able to get this yet. I hope that somebody here remembers it. We want to try to figure out the measure of angle theta. Talk to the person next to you and see if you can figure out theta. Go talk.
It's the same. What is that thing? We learned it.
I forgot.
We learned it.
What's it called? The area of the
Because it doesn't matter anymore. It's not like I'm first.
What'd you get?
We don't know. We know how.
So there's this thing in geometry where we say that a central angle has the exact same measurement as the arc it intercepts. So this arc is 116 degrees. We know that the inscribed angle is exactly half of the central angle.
Oh.
So an inscribed angle it hits all three parts of the circle. Okay, so I'll do another one. Okay, I'll do another one. Okay, see a couple. Okay. So suppose I have a diameter stretches from one side to the other. How many degrees does that intercept then if it stretches from one side to the other? Everybody agrees 180? Then it doesn't matter what triangle I draw that intercepts the diameter. What kind of angle will that be? A 90-degree angle. It is half of what it intercepts. An inscribed angle is half of what it intercepts. If you have a central angle, it is the same. So I'll just do one more. Got a common situation here where we've got, say, 60 degrees. Yay! So this is the arc it intercepts is 60. Those are the same. But if I stretch this over here, now this is 30 degrees, is exactly half. See that relationship I thought maybe you would forget, but one that we hopefully can know. You know how to do this. We are doing some trig work here. Sine, cosine, or tangent. Cosine of 32 degrees is equal to x over 24. You simply multiply both sides by 24. And somebody got an answer there? I can't do cosine 32 in my head. That's a tough one. I'm not a savant.
20.4.
20.4, so says Nevaeh.
Make sure somebody agrees with me.
I'm confident in you. Is anybody here not confident in Nevaeh?
I would raise your hand.
Isn't it interesting that sometimes if you look in the room, the person that's least confident about themselves is them. It's not somebody else, you know what I mean? Right? Like we're more likely to doubt ourselves than somebody else would, you know what I mean? It's a lot of times the way it goes.
Which is kind of scary.
Find the slope, distance, and midpoint between the 2 points. You're going to calculate these, but let's see if you can remember the formulas. What's the formula for slope?
Y2 minus
Y2 minus y1 divided by x2 minus x1. Good job. What is the equation for distance?
X.
x2 minus, take it away. Let's go. You got it.
I was going to say the midpoint.
Just say something.
X1.
x1 good. Squared plus
Y2 minus y1.
squared good. And then we got x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So those are your three formulas. Those are ones you want to try to remember. I don't see them often giving you those on the ACT or moving forward. Those are a lot of times assumed knowledge. Go ahead and apply it to these 2 points to see if you come up with the slope, the distance, and the midpoint.
So do you get like access to like things for the ACT? Like what do you get to like help us learn? You know what I mean? Like how do you know what's on the test?
So excellent question. So what I'm going based off of is all the practice tests I've done. So I've done about 10 of them. You know what I mean? And I just don't often see them give you those. However, the law of cosines, c squared is equal to a squared plus b squared minus 2ab cosine of c, that, anytime I've seen that come up on the ACT, they give that formula to you.
Okay.
I do not see them give you the formula for the area of a circle. I do see them give you the formula for the volume of a sphere. And so we're just kind of calling their bluff, you know what I mean?
Mm-hmm.
But ACT, they haven't. I wish they would. I wish they would put out a formula sheet for mathematics saying these are the formulas we'll give you, but they've never done that.
Yeah.
But I will say, regardless, there's a few points. There's the ACT and the MC, then there's also just moving forward in mathematics, these are ones you want to remember. You know what I mean? Kind of had that conversation with my son the other night. My son was hating on radians last night. He's like, do you ever use radians moving forward? I'm like, you watch your mouth, man. It's like, well, they're dumb. Why would you use them? Why would you just use degrees? Because you're an ignorant, immature mathematician, young man. That's why.
Would you say we're ignorant?
No.
with mathematicians?
No, you guys are astute, mature, learned. He's naive. Micah falls in the trap that he thinks that the only things important for him to know are the things that he likes and understands readily. Gotta break him down. Make him feel some pain. 3.
Kind of sounds like that's how you were, based off what you tell us about, like, how I would go about this problem. You know what I mean? Like, you would not listen to what the teacher would say, and you just do it yourself.
Yeah. So can I respond to that?
Yeah.
You were absolutely right. I remember the day I had a teacher walk in front of class. He put a problem on the board. I was a freshman in calculus class at St. Olaf, and he said, I want somebody trying to do this. Whatever. So I went home and I did it like in 3 seconds. I came back. He's like, so who figured out the problem? I said, I got it, and I put it up on the board. And he's like, oh, and he started talking about it. And I just started like chatting with my friend. I didn't realize, but he was showing the whole class how I was completely wrong. Like, what? And it turned out that the problem I thought I could do, it was impossible to do. I was like, what? In that moment, I began to understand I was very arrogant about it. But here's the problem. He was the first teacher I ever had where I was like, this is going to sound really arrogant, okay? But stay with me here. He was the first teacher I had where I felt like I wasn't smarter than him. Like, no other teacher I had could show me like something I didn't know how to do. I remember my teacher in high school saying, Kevin, just like, I don't know what you're doing. Just go do your own thing. You know what I mean? And so finally I had some, I'm like, oh, wow. And that was part of what was great in college. I started to see like, there was so much math. I was like, I had no idea. And it just very humility. A lot of humbling, a lot of like, wow, like I got to check my ego at the door. You know what I mean? Mm-hmm. So yeah, without a doubt, like I was in high school, I was like, why are they doing like that? I'm just doing like this. And teacher could never really tell me why my way wasn't better or more efficient. Got my butt kicked a couple times in college. Yeah. But that's why it goes. This is 13. And then this, we had negative 8.5 and positive 16. Is that what you got? There you go. We flip it over. Last page. Write an equation for a circle with the following properties. Center negative 5 and 3 and radius 8. Does anybody remember how this is going to set up?
X
Yes.
plus 5
Yeah.
squared
X
minus
plus 5 squared. Yep. And then
X minus
y
Y
minus 3 squared is
8 squared.
64. Good. Now, as you struggle to remember that because you wanted to put 8, right? That's exactly what you see on the ACT. They'll have 8 as one of the options there. And here's how you know. This simply comes from a squared plus b squared is c squared. You see it? It's the Pythagorean theorem. Just like the distance formula on the other side. It is the Pythagorean theorem right there. A squared plus b squared is c squared. So we square root it. That's all it is. And that can help you remember to square that piece. What is the center of this guy right here?
6 negative
So
7.
negative 7, and then the radius is the square root of 20 or 2 roots of 5. Should be able to handle some basic, and I mean basic, statistic operations. For example, you should be able to find the mean, median, mode, quartile 1, quartile 3, interquartile range for a box and whisker plot. You did box and whisker plots back in 8th grade with Miss Kruger. Remember those good days?
Yeah.
I always make a box and whisker plot for you every time we do our test to try to help you with these moments right here. Let's just start with the basic operations such as mode. What is the mode? The mode is the number that occurs most frequently, which is going to be 8. And then I'm going to go to the median next. Median is the middle representation of the data. And so the way I find the median is I cross off the lowest and the highest. The lowest and the highest, 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 and there I am. The middle number is 8. once you have the data split in half, and by the way, somebody asked, what if there's 2 in the middle? If there's 2 in the middle, then you average them, okay? But so anyway, so since that's the median, then I try to find the quartiles. I cross off the smallest and then that, and smallest and that. I get to 7. That would be quartile 1. And then quartile 3 is going to be 8.5. So as you sketch a box and whisker plot, you always plot the minimum. The minimum is 3. The maximum is 10. The first quartile is 7. The median is 8. And then I got 8.5. So the middle is what makes my box, and then the ends are those whiskers. So that's a distribution of my data, and that could give me a really good visual picture. You guys never made these? Wow. Holy cow. So it's cool. You guys kind of learned from me that I said, that means that 25% of your data is right here. So that means 25% of the kids score between 8.5 and 10. 25% score between 8 and 8.5. 25% between 7 and 8, and then 25% happen to score between 3 and 7. They're not as happy, but the rest are pretty good scores. We feel good about that. The interquartile range simply refers to the distance between the first quartile and the third quartile, which is 1.5. And obviously the mean is simply what? Yeah, I'm sorry. The mean we compute it by doing adding them all up and dividing by the number. It's just the average, yeah. So we move on to scatter plots. Do you guys remember looking at scatter plots last year at all?
Yeah.
Okay, so these all either have positive or negative correlation, and they are either regarded as strong correlation or weak correlation. So see if you can label which ones are positive and negative, which ones are strong and weak, okay? Okay, positive and negative, we determine by if we were to draw a line, a best fit line. Notice the best fit line has a slope that's negative. The best fit line is a slope that's positive. And it's easy to draw that line, so I would say it's a strong correlation. Whereas here, it's difficult to figure out exactly where the line goes. Does it go like that? Does it go like that? I don't know. So we'd say that this is a weaker correlation. Now, the fact is that this one, I would say that this seems to be weaker, and this one seems to be strong, but these are a little bit more mixed. They're kind of in the middle in terms of type of correlation, okay? But you should be able to compare weak, strong, positive, negative correlations. And finally, we get to our last part, which is counting and probabilities. Jake, Sarah, Cole, and Ava are standing outside the line waiting for ice cream. What's your favorite kind of ice cream, Brian?
Salted caramel.
Salted caramel. How are you? Cookie dough. Good. I like cookies and cream. I really like peanut butter and chocolate. That'd be my favorite.
Have you ever had Urge Tracks from Quick Trip?
Yeah. Yeah, it's good.
Or I guess is it Moose Tracks or Urge Tracks? I don't know.
I've had a both, but I really just like the it's a solid chocolate and then just like peanut butter chunks all throughout it.
Like the ribbons.
Oh, yeah, I can have that too. It's I just love it. Good old peanut butter and chocolate. Yeah. So anyway.
That's what ice cream really took my really ice cream. Peanut butter around like chocolate, like
So if we're going to arrange them in line, that's one way to do it. But we could also put Jake first, and then we could put Cole next. We could put Ava next, and we could put Sarah all the way at the back because she always buds in line anyway. Like, how many different ways are there to arrange those 4 people in line? Talk to the person next to you. How many ways can you arrange those 4 people in line?
Oh, there isn't 8 people, there's only 4. I was thinking there was 8 people.
Yeah, no, there's just 4
Doubles
people.
that were about 4 power. No.
How many choices do we have for the first spot?
4.
We have 4 choices for the first spot. Once that spot is filled, how many choices do we have for the next spot?
3.
Then you have 3. Once you have the first 2 spots filled, how many is available for the next? 2 and 1. Or in other words, 4 factorial, 4 times 3 times 2 times 1, which is in fact 24. So it's 24 different arrangements. Jake likes vanilla ice cream. There's 6 toppings to choose from. He chooses 2 toppings. How many different combinations could he possibly choose? If you're looking at combinations, there's 2 ways to do this. Please take out your calculator. This is the one that I taught Ron earlier, because I just thought I would remember everything, and you know what? Sometimes we forget, and I didn't remember. Are you okay with that? Forgiveness?
Yep.
Thank you. Appreciate that. So when you're considering a combination, here's what I want you to think about. Does it matter? Let's say he's going to choose chocolate and caramel for his topping. That's why if I have vanilla ice cream, I choose chocolate and caramel. So I put on mine, okay? So I'm choosing chocolate and caramel. Does it matter if I choose the chocolate first or the caramel first?
No.
No. So in that situation, order does not matter. And when we look at this, you can either have NPR or NCR. This is called a permutation. This is called a combination. And a permutation, order does not matter. And in a combination, order matters. So in this situation, what I do is I do a 6 permutation 2. Okay? And we can simply perform that on our calculator. And I'll show you how to find it. Super easy. Do you guys remember doing this in 9th grade? This might have just gotten left out altogether. No big deal. It's just a small thing. So we're going to press 6, and then you press the math button, and that's where your probability stuff is located. And so I go over to probability and see how it says NPR. That's what we grab. We grab number 2. And we said that we choose how many? 2. And that computes it, and we get 30. Okay? I think I taught it wrong again. Is permutation the one where order does matter? I can't remember. Okay, anyway, if you do N choose R, so we'll just switch the situation. Suppose that there were 6 people that were competing in a race, and first place got 5 points, and second place got 3 points, and nobody got points after that, okay? Do you agree that there's only 2 people that are going to get points? Does order matter in that situation? Absolutely. So then we would choose the other one. I'll clarify this tomorrow whether this one has order matters or this one. I can't remember. I'll have to look it up. I've lost it again. Last 2. There's 60% chance of rain today. There's 30% chance that Matt's going to fail his math test. What's the probability that Matt has a sunshiny day and he doesn't fail his test? Talk to the person next to you. What's the percent chance he's got a great day ahead of him? Talk. What do you think?
40%.
Do something.
40%. 70%.
So, 40%.
So it has to have.
Okay, let's pause. And I see that there's a 60% chance of rain today. That means there's a 40% chance that it doesn't rain today. And then I also know that for Matt, there's a 70% chance that he does pass his test. And so in this moment, you're like, hey, he's probably doing pretty well. Yeah, he's doing well for the test for the most part. But the fact is that if you multiply these two together, you get his total outcome where it's a 28% chance that it both rains, that it has sunshine and that he passes his test. So most likely something's going to go wrong today that he doesn't want, okay? And just for note, I'll go back and talk about it later, but I have these mixed up. Permutation does matter for order, and combination does not. My bad there. I'll clarify that tomorrow. I'll have a good example. I'll be organized. Last example, okay? Here's a table. We are going to choose a student from a math class. Okay, we're going to choose a student, not an athlete, from a math class. This math class has 36 total students in it. And the question is, what is the probability that we select a junior? Notice it's divided among boys and girls and juniors and seniors. What's the probability that a junior is selected?
26 out of 36.
Yeah, 26 out of 36. We could reduce that. What's the probability that we randomly select a boy? 14 out of 36. So easy to read the table and see that. The next part is a conditional probability. So what this means is, what is the probability of selecting a junior given it's a girl? So we're only selecting from the girl population. So all I do is I just focus on this grouping here. So what's the probability I select a junior given it's a girl? 16 out of 22. Probability I select a boy given it's a senior. So if it's a senior, I only look at this row because I'm looking at just seniors. Probability it's a boy given it's a senior? 4 out of 10. Probability it's a girl given it's a senior? 6 out of 10. Probability it's a junior given it's a boy. If it's given to be a boy, then again, I just focus on this grouping here. And a junior, given it's a boy, is 10 out of 14. Okay, so this is I told you I'd have Form B for you. I will not let you down. This is due on Monday. These are basically the exact same questions that we've just went over the past couple days. We'll score it on Monday. I need 70% of you to do 70% or better. If you don't, we're going to have to find another time to do a little bit of review. But I'd like to move on to other stuff. Okay? I'd like to move on to other stuff. Okay? I just found out today I'm proctoring the ACT. So I'll be in the gym. We're taking the ACT in the gym. That's going to happen coming on up here in a couple weeks. Nevaeh, you asked about the score, so to speak, for how they're scored. I will have that as well as practice tests ready to go tomorrow. There is a possibility that the boys and girls track team ends up at Gustavus College on Thursday. If that's the case, I will be there during the day and I won't be here in this class. I apologize for that, but we'll find out tonight. Last thing is, tomorrow we start kind of our normal trig unit stuff, okay? So if you were a person that finished, such as Gina, she finished her solving trigonometric equations assignment right away, remember that? And you handed it in with your homework, I handed it back to you the other day?
I figured out that's why I couldn't find it, because I turned it in, so I grabbed another one and started.
Okay, all right. So she's got that one, so she's all ready to go, okay? But if you haven't done that yet, that's kind of what we pick up with tomorrow, okay? So you'd want to refresh yourself. And I'm not just going to start cold into something brand new. We are going to review that a little bit, so we'll go from there.
Guess what time would we